I am going to be talking about some work that we do inside of CISO around the Presto DB's Thrift connector and how we use it to accelerate queries for our security analysts and other cybersecurity needs. Takeaways that I hope that you get from this. So first one is database internals aren't that scary. You can work on this stuff, pretty safely. There's a lot of guardrails out there and a lot of really easy ways to get to it. Sometimes, if you do something new, it can help you scale better, and you can generally get away with it. And then the third and the hopefully most important piece that you can take away from this is the fact that, is this problem that I'm running into a problem that you're running into? Because while my solution might not necessarily be your solution, it can at least help guide you through all the potential things that we get to deal with because the world is turning complete. And there's so many ways that you can solve problems with computers, like BOGO sort is a thing, and it's just something that you're going to have to think about. So I'm going to cover what we try to do inside of CISO from a security perspective. I want to cover our existing architecture, the elephant in the room that kind of led us to why we want to do this, and how we were able to start over using Presto's Thrift connector to go and let us accelerate our query workload and eliminate a lot of the issues that we were currently running into with some of the existing open source approaches. So this is what I try to do. Mostly as my day job, unless something terrible happens. I'm in security, I'm on an operations team, even though I'm an engineer. I have to grab me, myself, everyone in my team, all around the world. We grab all of IBM's cybersecurity relevant data. This is logs, system events, asset inventory, vendor reports, anything that IBM purchases that has a network card in it that connects to a corporate network. I need your security logs. You have to give them to me, and I have to store them for around 2 years, in some cases up to 10. We also do near real-time analysis and evaluation. So by the time that you send me the log, I need to get it into storage in 500 milliseconds. And I need to make sure that those capabilities can drive all the alerts that are present in our security operations center. So this means as we see problems, as we see attackers coming in, trying to go after IBM, I can go and flag those events so we can actually highlight them to an analyst, and then they can go and use fast querying capabilities on roughly 2 years of historical data. Again, it's going to go up to 10. This is all hot, by the way. I can't tier data down. It all has to have the same access pattern, which right now is ON, and yeah, kind of scary. And this drives a lot of our capabilities. So this is, we have to look at something now. We might be looking at, say, like a couple of days worth of data, or we get a report in, like most recently what happened where some telecoms got compromised. We're going to take that report, try to validate and make sure that, hey, did we get compromised by that same group? And this is where we're going to have to scan all 2 years worth of data in essentially a needle in the haystack approach, look through everything that we have to see if we find anything close, which, as you can imagine, can get kind of time-consuming and expensive. And finally, I'm a free service provided to IBM. Like, I get paid through budget that's collected from everyone else inside of IBM. So everything I do has to be really, really cost-effective. I'm not, a SaaS vendor or provider where I go and charge people for my services. I just have to, do my best to keep this, cheap and free as possible, because at the end of the day, you need security if you're inside of IBM, because every customer that depends on us needs that security too. So the nice part, though, is I only really care about like 2 terabytes worth of data a day. That's not that bad in the grand scheme of things. You multiply that out, it's like a couple petabytes. No, the problem is it's the 250 terabytes a day and rising of maybe security relevant data where we think it could be useful at some point, and we're going to keep it because we need to, but we don't necessarily know if it's actually relevant. I checked. We look at maybe 1% of our data on average, except in certain critical times of the year where we're scanning everything repeatedly. So this is one of these things where it's not like I have a nice, standard distribution. I'm horrifically bimodal when it comes to what people want to look at. And this then kind of leads to our architecture. This is like as simple as possible. We grab everything in. Generally, it's coming in through the rsyslog protocol, or we're going to collect it from like an HTTP API or object storage. We throw this onto Kafka. We have a big Flink normalization process that we roll out, converts it to our schema. We throw that process data onto Kafka, so we send it off to an alerting engine and a storage engine. The storage engine throws it into object storage. We hit it with a bunch of SQL engines, Presto, ClickHouse, anything that we can grab from IBM Cloud, DB2 Warehouse in some cases. What's the other one? Netezza is kind of fun to use on this stuff. And then we throw UIs on top of that. So this is going to range from BI tools like Cognos and Power to open source stuff like Superset and Metabase. And this basically gives us like a nice modular stack where if analysts need a particular view, we can give them that particular view, because at the center of this, it's our lakehouse architecture where really we just tell people, okay, hey, depending on the level of security that you need and the controls that you need, we're going to just set you ANSI SQL, which everyone knows and everyone can handle. And again, that makes it pretty simple. And for us, today and previously, we're using Apache Iceberg. This is our new data architecture, which looks exactly the same as the old one because I just duplicated the slide. And what we're basically doing is we're going to just play the Indiana Jones sandbag game, and this is what's happening at Christmas and into next year, where we're going to swap out Iceberg for our custom storage format because of the elephant in the room, which is Iceberg. I don't think Iceberg is a bad format, but I think for a SOC use case where I am an append-only event stream of data, there are enough problems with a team of essentially 3 to 6 individuals that work on this to where we need something that's more consistent. Our write performance is not particularly good with SOC at the rates that we do, and the fact that the amount of data that we need to write peaks at random, where we'll have certain systems that will dump terabytes and terabytes of data and then do nothing. So our Kafka cluster will scale itself up and down basically 26 times a day. I mean, it's great it can handle that, but I don't have, say, like a consistent tick of data coming in from a known stream. I just have to take everything that I get. Because we use Flink and it's checkpointing, that has issues because our checkpointing times get weird, or you have to do micro-batching in Spark, which has the overhead of needing to now run a Spark cluster in addition to everything else. We've seen tables inconsistently fill with data where certain chunks will appear before other chunks, which from an analyst perspective, especially in high-profile incidents, gets very annoying, being told, okay, hey, wait 20 minutes and then run your query again. Memory utilization gets inconsistent, which this is basically our #1 source of on-call pages. Somebody dumps a ton of data at us. Every single part in the system handles it fine until it gets to Iceberg, and then Iceberg is like, I actually need, a half a terabyte to save this, which is kind of ridiculous. And then compaction's just broken unless you're using Spark. The code that is produced for Flink is non-functional as it stands in the open source repository. And I mean, we just now have to run a Spark cluster in addition to everything else, which has performance implications because compaction is the #1 way with Iceberg and other lakehouse formats that you can keep things running fast, running effectively. The other issue is Hadoop, and this is where I want to talk about the elephant. So if we think about Maslow's hierarchy of needs, everything that you as a person need to reach transcendence, be self-actualized, there is a group of people in this world, I feel like you're in this room, and but there's this need to use Hadoop for things. And as a cybersecurity individual and in an environment where I don't use x86 processors for certain projects because I'm afraid that there's malware embedded in things that I have to work with, and I'm going to grab something that's completely weird and exotic just as an extra layer of protection, you get issues like this where, transitive dependencies with CVEs in Hadoop. And I need these things fixed, unfortunately on a pretty tight timetable because I'm in security and I have to demonstrate that I have good security practices. So when I go and tell people, hey, we need to upgrade your security practices, it's like, go throw stones in your glass house. No, it's load-bearing. Hadoop is load-bearing for a lot of the data ecosystem, even though we're not running a Hadoop cluster with HDFS and all this other stuff. Parquet and Orc, to an extent, depend on Hadoop. Iceberg, if you're using it with custom catalogs like the Nessie catalog, you need to have Hadoop in your class path. Flink needs Hadoop in its class path to write to object storage, and you just get this surface area of libraries. Like, I don't use Kerberos support, but I'm still going to get dinged on every Kerberos vulnerability, and because the code is in the class path, if there's a vulnerability that can chain into it, I have to be ready to handle that, which generally means being on top of all these updates. So when we think about, starting over, and, this is kind of the point that we're at, we have a system that inherently is causing a maintenance burden, and my option is okay, I could patch the issues in Iceberg, sure, and, those are going to, on long term. I can fork Flink, sure, and, help with that long term, but it's also one of these cases where, we also have to think about queries when you think about data systems. And fundamentally, when we think about starting over, I think about two types of queries. So first off, this is a query a class of analyst is going to run. Nice and easy. Pick two columns from a table, have a timestamp in place, filter on an ID. This is great. This is easy. Everyone knows how to optimize this. The other problem that I run into is that I have analysts that will run queries like this. This is not valid SQL, but if this was valid SQL, they would try to run it. And I know this because I pulled this from the errors table I keep of every invalid query. I changed the like to protect the actual customer that was involved. But this is the type of query that I'm also being asked to run where I need to essentially look at every single thing that I have in that 250 terabytes a day times 2 years and find a string of all things, and we all know how good strings optimize when it comes to search, because we're trying to find someone that might have done something to us, and we have to do this exhaustive search. So this is now me just dreaming, wouldn't it be great if I could solve this problem, because I'm kind of in this weird trap state. So I want columnar storage because we know columnar storage is fast. I kind of want a schema, but I also don't. If you've ever read the TUM JSON tile people, that's what we're going for and have been pushing on, which is great, because I can pick and choose when I have a schema in columns and when I just have a blob of things. There's certain types of content-specific compression, so we're all log data. If you've never read the Yscope CLP paper, it's amazing. I know that these functions are built in Apache Pinot, which has its own special issues, but it's 200x compression on syslog data, which is great. There's a lot of domain-specific stuff I can do because I know my data, I know my queries, I know that people are going to say bad guy, and I have to give you those results. I'd love to be cheaper than Iceberg in terms of memory utilization. I don't want a metadata service, and because I work at IBM and I don't have to actually have my things run anywhere else but the environment IBM gives me, I'd love to use Aspira's fast support because then I can fully saturate my network interface and basically bound myself on I/O in terms of querying, so I know that everything's going to be hot and gets rolled through. The other nice part is, and this is where I'm saying know your problem, know your data, I don't need to do things that all these other formats do. By design, I don't want to modify my data. Modifying data is terrible. It means I've caused an issue with compliance. Everything is immutable. I don't need to delete records. I don't need to change records. I need to get the data in a format that is essentially cryptographically secure that I've not modified it, and then stick it inside somewhere and keep it forever, and then delete it only when I'm deleting it in batches. Because again, I'm append only. Everything has a timestamp. I can say that 100%. I don't deal with data without timestamps. Don't need to write into the past. I just have to write to the head. If I age data out, I can delete it in batches, and it's really great, and it's really easy for that. And when you take all this stuff together, the dreams aren't necessarily that out there, but there's this other elephant in the room that you kind of run into, and this is where we reach for stuff like Presto, honestly, is the fact that it is the technology that takes you there. I love this quote, Eskil Sternberg. I used to do computer graphics. He's my hero when it comes to CG stuff. Most users need tools. So I can build a thing, like a storage format. You need tools to make it usable, like RocksDB. I know Meta did that. It's great. I love using it. When I do C++ stuff, it's this super awesome library. But the problem with RocksDB is it's one piece of the entire puzzle. And for my technical and semi-technical use case where I'm giving a SQL database to folks inside of IBM to do cybersecurity analysis with, having just a storage format that's better than the storage formats that exist, it helps no one but me, and even then it doesn't really help me because people still need access to that data, so I still have to give it to them. So when you go back to RocksDB, it's great, but you have to query it. You have to have tools on top of it to make it useful, and this is where you saw MyRocks, which is still kind of around, where you take it, you wrap it inside of something else, to get users that maybe just know SQL but don't necessarily know how to use the C++ library can take advantage of all the value that RocksDB can bring. And this is the same thing here. The really nice part is with the data science ecosystem today, you can tackle a database in pieces. You have tools like Velox, Greenplum, Orca, where it's, hey, you can just have a query engine and go and build everything else around it. You have Data Fusion and Rust, where it's the equivalent of getting a make your own sandwich kit at an airport, but for a database, you can use or not use their query layer, query execution layer, data storage format. All the cool constituent components is just free and easy for you to go and play with. Or you always have stuff like Postgres foreign data wrappers, which are increasingly becoming a new way for, it's like Postgres age for graph data, time series DB, and just all these other extensions to make its way into Postgres, to where you have everything that Postgres gives you, which is great tooling support and known database structures. You throw that in there, you get your data format tied into it, and then you can use your catalog and run queries. Because again, you can tackle a database in piece, but you can't tackle tooling in pieces. So when you have things like Tableau, Power BI, Superset, Metabase, DB for data grip, data lore, Jupyter Notebooks, SQL Alchemy, all of this ecosystem support, that if you say, hey, I have made a completely new from-scratch database, and you have users that are not inherently technical and are not going to be building these tools on top of it, you have to provide all of this. And when you're me and you're starting over again, I'm 33.3% of the team on a good day here, so I don't have the bandwidth to write an entire series of analytics tool and a custom database and everything else that I need to do, because I'm in security and an operations team. And the second that I wake up, I'm like, am I going to get a text from the C-level that I have to go do something crazy? And most of the days I don't, but on the days that I do, that's possibly my month. You have to scope down the work to get the most value and make sure that you're delivering business value and ultimately customer value without necessarily writing the reel. Because while I would love to, have a team of 250 people to do this for me, I don't. I have me and a couple other folks that help on a rotating basis, and a couple other folks that help on a permanent basis. Like, I can't go and build an entire set of analytics tools and a completely custom database engine to power all of this. And this is where I love Presto DB, and I love this Thrift connector, because the idea is that I can take Presto and the fact that there's so much stuff that can talk to Presto, understands Presto, handles security, deployment, use the Helm chart, use Cognos, Tableau, all of these tools to work with it, all just for free. And all I have to do is convince Presto and explain to it, hey, I'd like you to talk to my custom data format. So this is really, it's doing this. And this is difficult to read. You don't need to focus on reading it. But you have this one Thrift IDL, and at its core, you care about 3 methods. And if you can describe those 3 methods and explain to it what your schema is, what tables you have, and how to give it data to go and process, you can make Presto handle everything that you need it to. And this is, again, great, because from my perspective, I'm going to do 3 simple things and have my custom storage format. Presto's going to take care of everything else that I need to. I get joins, I get functions, I get reporting, I get tools, I get user interfaces, and ultimately to the end user, it's just like, yeah, I just run a SQL query. They don't need to understand I've gone in, upended the entire world. At worst, they change a catalog, and at best, they have no idea what's going on. So again, 3 methods. Method number 1, you need to explain to Presto what tables there are. So you're going to give it a name, you're going to give it a list of columns and types, and you might give it a comment. Then if you really want to get fancy, you can give it indexable keys. And if you start giving it indexable keys, Presto will call extra methods to go and make sure that you can use those indexable keys to help accelerate queries. So this is basically predicate push down on arbitrary data sources, which is great. You can also skip this to get started, and Presto's just going to ask for all the raw data and process it in memory. And again, this is how I started. Just shove everything over to Presto, let my worker nodes do it. And then once I had a handle of what the format's going to look like, what it needs to do, how I want my indexes to work, I just start telling Presto, hey, these columns can be indexed, and it will give me that metadata so I can go and use that to cut in on the amount of data that I want to send back to Presto. And then again, set number 2, you're going to take your table by name and by columns and by tuple size essentially and number of splits, and just give it batches of data back. Just again, you don't have to care about anything about the data. Just shovel it out the door. Presto's query engine is going to handle the rest of it. And then finally, when it wants to go and actually look at a split from that list of splits you previously gave it, just go and tell it, hey, here's a row of data, here's a row of data, here's a row of data. This is really simple. And if you get all 3 of those things taken care of, congratulations, like you're connected to SQL. And this is what we did to solve our problem. We just took our proprietary data format. We explained to Presto how to go and do that, and then I did more work to explain to it how to go and optimize it with index pushdown. And I've kept all my tools. Users are going to have to change a catalog from name A to name B, but I get to use Cognos, I get to use Superset, I get to use Metabase. Any tool that can talk to Presto can now talk to my format. I have joins, I have functions, I have temporary tables. I don't need to implement Grace. I don't have to worry about disk spill. I don't have to do the hard parts of the database, and this is what Apache Pinot did for a while. I can go and just let the thing run and handle the data processing need and only focus on that portion of my problem. And then finally, I get to do all the crazy stuff that I want, and Presto's just going to keep working. So as long as I never break the contract between me and Presto at that Thrift layer, I'm free to do whatever I want on my database storage side. I can accelerate the internals with stuff like PowerPC and mainframe-based assembly instructions. I can run this service basically anywhere that I need to on as much hardware or as little hardware as I want. I can write the data in any fashion that I need to, whether it come from Kafka, direct from consumers, all that fun stuff. I'm free to do whatever I need to make my problem go away, which is the fact that Iceberg has been having, memory issues and capability issues. And from there, it's entirely up to Presto to actually handle the query piece, and you don't break the contract, it just works fine. And on that note, going back to this absolutely horrific query, and you know who you are watching the video back when it's been posted in Town Hall by Kos, and I'm coming for you because I'm really unhappy about even having to get to this point, folks. I can just skip over 99.6% of the data that you're trying to look at. This is a synthetic benchmark. This is the only benchmark I'm going to throw in here because it's mean to go apples to apples with stuff like, Prestissimo in this case, because I've built a format to handle my queryal workload and I'm benchmarking folks against my queryal workload, but 99.6% of the data skipped. My traversal is n log n versus on. For your traditional, I'm going to scan everything. So queries like that might have taken hours and days are going to take minutes. And on that fun note, I am Hunter Madison. If folks have questions, I'm more than happy to take them.